When it comes to graphing polynomials, we need to be experts in all sorts of factoring and solving, because depending on which type of equation they give us, we may need to use X factor or factor by grouping or other different methods of factoring so we can actually graph these polynomials. The way we're going to start this off is by analyzing what is called the end behavior, how the ends of these graphs are going to turn out. So I'm going to draw this as a little table here. Okay, so we have a couple of options. The biggest exponent could either be even, and we'll call that even degree, even exponent, or the biggest exponent could be odd. So it's either odd or it's going to be even. Now, the lead number, the a value, could either be a positive coefficient or a negative coefficient. So remember, if things are positive, they go up. If things are negative, they go down. All right, so let's think about maybe a parabola where it's x squared. X squared being an even degree. Okay, so we have four different ways these could turn out. If it's exponent 2 or 4, 6, 8, something with an even exponent and it's positive, both arms on the ends of it are going to go up. There might be some twists and turns in between, depending on what the exponent actually is, because if we connected those, that would be a parabola. Now, if it's even and it's negative in the front, everything's going to go downwards. And I'm not going to connect them because there could be twists and turns in between. Now, if it's odd, exponent 3, 5, 7, 9, and so on, the arms are going to go opposite directions. And if it's positive, it's going to go from low to high. And if it's odd and negative, it's going to go from high to low. And I'm not connecting these because of all the possible twists and turns there could be in between. The other thing that we're going to use to graph will be the X-intercepts. So I'm going to make a note of that. We'll graph these using the X-intercepts. And you'll probably say, why does this even go with our solving and factoring? Because remember, X-intercepts, other words for those are solutions or zeros. Okay, these all are asking us to solve the problem. So x equals blank, 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 whatever those numbers are, those will be the X-intercepts. Now let's go ahead and start this off nice and easy. Let's say they gave us an equation that was already factored. Okay, they gave us an equation that's already sets of parentheses. So negative x plus 3, x plus 2, x minus 1, and x minus 5. So this is already factored. It's already in parentheses. We want to see how this was made. If this was multiplied all the way out, x, 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 x. If we multiplied all those x's out, it would be x to the 4th. And the reason we want to know that is because of the exponent. That is even. Let's look all the way into the front. It is even and negative. So let's find that little box up above, and it'll tell us how the arms of this shape are eventually going to go. Even and negative. So if it's even, the arms are going the same direction, and negative would be this one right here. So both arms are going to be going down eventually once we graph this. So I'm going to make a little note of here. We got arms both going down. Now if we were to find the X-intercepts, we would set this equal to 0. So x plus 3, x plus 2, x minus 1, x minus 5. And we would set each of these equal to 0 and solve it. So like this would be x plus 3 equals 0, and x plus 2 equals 0, x minus 1 equals 0, x minus 5 equals 0. And once we actually solve those, we get a -3, -2, +1, and adding 5 gives us a +5. Or maybe the faster way is just flip all these signs. All these are opposite. Whatever we see in the parentheses, it's opposite in our answers. So these are all my X-intercepts, and I want to remember that, okay? Because these are things we'll want to graph. Now another thing we'll want to find are the Y-intercepts. Usually there's just going to be one of them. For the X-intercepts, we change the Y to 0. For the Y-intercepts, we're going to change the X to 0. So make a little note of that. I'll put that in brackets so we know that's not some sort of answer. So we're going to say Y equals, but now I'm going to flip all the X's from above into zeros. So here it's a little funky because we have lots and lots of parentheses. But we're going to plug in X equals 0. So Y equals negative. That's a 3, that's a 2, that's a -1, and that's a -5. And if we were to multiply all 4 of these numbers out, we would get to Y equals -30. So there's my Y-intercept. So we have X-intercepts, we have Y-intercepts. This is all something we can graph. Now we're not making the best graph possible, we're just finding kind of how this looks. We want the general idea. So my X-intercepts. I have X-intercepts at, let's see, -3 and -2. So here's -3, here's -2, +1 and +5. I need one more over here for +5. Okay. I know that there's a Y-intercept at -30, and I can't get 30 lines on here, so at least I'll just say this is -30 and put my point on that. So we graphed X-intercepts, we've graphed Y-intercepts, and what we're going to do now is put the end behavior on. So my end behavior, remember we noted that before, both arms at the ends of these are going to go downwards. So find the farthest point to the left and farthest to the right. These are going to go downwards. And now what we're learning today is how to go through these. So kind of follow the pattern here. I want to go through this point, I'm going to hook it through here, I'm going to hook it there, and you'll see this works out nicely. Okay? So obviously this could go a little higher, it could go a little lower. We don't know for sure because we don't have points for those, but we're just doing our best. But we could label these if we wanted to as maxes and mins. So maybe something right here, this is a max, it's a high point. We also have a max here. We have a low point here. That's a min. Okay, so we just want the general forms of these graphs. So for right now, that looks pretty good. Let's take a look at another one. All right, so we want the X-intercepts, we want the end behavior, and that usually gives us a pretty good idea of how this polynomial is going to be graphed. So here's our next example. We've got Y equals X, X plus 5, X minus 2, and X plus 3, whole thing squared. So now if we try and analyze this, we want to find that end behavior. Let's look at it. We have X, 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 and X. It looks like 4, except for this. There's 2 of them here. So that's actually going to be X squared, 3, 4, 5. This is X to the 5th overall. That is an odd exponent. And we look in the front, positive. Odd, positive. So let's look back up at our chart in the beginning. Odd, positive. Odd, positive. Odd, positive is this one here, where my arms are going from low to high. So end behavior, low to high like this. Twists and turns in between. Now the tricky thing is, this one doesn't have parentheses. We can throw it on there, so actually there's a +0 in there that we don't see. So if we were to find all these X-intercepts, just take the opposites, 0, -5, +2, And what this means is that there's two of these. So a -3 and a -3, that there's two of them. If we were to plug in 0 for all the x's, my y-intercept, notice this, I plug in 0 here, that's 0 times everything else is just going to 0 it out. So let's go ahead and try and graph this. So my x-intercepts, 0, -5, +2, -3, and then -3 again on top of each other. Interesting. We have y-intercept at 0, that already exists there. Let's go ahead and put these lines on. So I know my arms need to go like this. This one going down, this one going up. Now I'm going to change the color and you kind of watch what's happening here. If I were to go through this, you see how that doesn't really make sense like last time? Let's try it from the other way. It's hard to do that. So what we're actually seeing here is a special case, and you want to make a note of this off on the side somewhere. Make a note of this. What's special is that we have these two numbers. So right now, make a little note. If you have repeat numbers, be careful. Alright, so once numbers start to repeat, fun things happen. And here's the general form for it. If you have an odd amount of the numbers, so for example, if you have a 1, 3, 5, 7, or an odd amount of an x-intercept, what you're going to do is cross through that point. If you have 2, 4, 6, 8, or an even amount of an x-intercept, what you're going to do is you're going to bounce off that point. So let's analyze this and see what they mean. So we got cross through, we got bounce off. So if I look back to my first equation up here, I have 1, -3. I have 1, -2. I have 1, 1. I have 1, 5. They're all singles. Not what number they actually are, but how many there are of them. I have one of each. That's why we crossed through every single one of these points. Now these ones here, if I list them out, I've got one of these, one of these, one of these, 2 of those. That's a double. Anytime I've got an even amount, I'm going to bounce off of that number. So that's happening here at -3. So let's see what happens. Everything else is a cross through. This is a cross through. This is a cross through. This is a cross through. But once we hit this point, I'm not going to cross through it. I'm going to bounce off of it. And you see how that leads me back, whoops, to the other piece over there. So instead of going through it, I'm going to bounce off of it. Now obviously some of these maxes and mins can be a little bit higher or a little bit lower, depending on how it would be drawn. But for right now, we have a pretty good idea of how this graph is going to go. The thing to remember here is anytime you have an even amount, if you have odd, it goes back to cross through, but if you have an even amount, you're going to bounce. I put even. Okay. So let's see if we can tie this into an actual unfactored equation. So let's say we want to go ahead and graph the following. Y equals x cubed plus x squared minus 9x minus 9. Not factored yet. We learned a lot of ways to factor. This is 4 pieces. This is a factor by grouping. And remember, I want that plus sign in between. GCF the first bit. X squared, leaving me with x plus 1. Plus, I'm going to factor out a negative 9, leaving me with x plus 1. If we have matching parentheses, we've done it right. X plus 1. Everything else gets put in the second set. Now I don't want it equal to 0. I want it now set equal, or I don't want it set equal to y. I set it equal to 0 because I need to solve this. I can split them. X plus 1 equals 0. X squared minus 9 equals 0. So solving this out, x equals negative 1. There's one x-intercept, because that's what we're finding here, x-intercepts. The other one, we add 9 over, we get x squared equals 9. Square root both sides. Square root of 9 is plus or minus 3. So let's list it out. My x-intercepts, negative 1, positive 3, negative 3. None of them repeat. I have a positive 3 and a negative 3. Those aren't the same. So no repeats. And with no repeats, no bouncing. Everything's going to cross through. For the y-intercept, if we go ahead and plug in 0 for x, that's a 0, 0, 0, minus 9. My y-intercept is going to be 0, negative 9. So this is all information we can use to graph. Definitely things are skewed towards the negatives. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's see over here. I need to go, let's see, 3 in each direction. All right, so we'll make note of it. I have x-intercepts at negative 1, positive 3, and negative 3. I also have a y-intercept at negative 9. Something that we skipped over was the end behavior. Let's look all the way back in the beginning. Since it's not factored, I just look at the biggest thing. My biggest exponent is 3. That is odd. It is positive in front. Odd positive, remember, goes from low to high. So let's put those arms on here, low to high. Low, high. No bouncing, so I'm going to cross through everything. I'm going to cross through this. Whoopsies. Cross through this, hit my y-intercept, cross through there. Okay, and that's all we have. There was negative 3, negative 1, positive 3, and then finally that's a max somewhere around there. We've got a min somewhere around here. All right, so finding x-intercepts, y-intercepts, and then following our end behavior table gives us a great idea of how we can graph these polynomials.